Hello everyone, welcome to session 7 on isometric projection. See here, in this session 7, again as usual we have started with the main problems itself, and the usual problem what you get is two solids, one above the other and all that. Okay, here they have said the base will be a square prism of sides 80 and height 20 or thickness 20, and top solid is a cone of diameter 50 and height 70. Okay, this has to be placed centrally over this. This is the problem. Okay, but you should know that this problem has been done already. Okay, you do this in the way I have done in the earlier sessions. Okay, in the first 5 sessions these problems have been covered, and to make it easy I am telling you again, at least here. Initially you take 100, 100, 20 only, the same thing, and select the entire thing, multiply by 0.816 scale factor, so that this will be ISO 20, ISO 80, ISO 80. Okay, this will be ISO 80 means it is actually 80 into 0.816, 80 into 0.816, 20 into 0.816. These things we'll do because they are clearly asked in this problem, not isometric view, and it is isometric projection. Also you should know, whenever whenever sphere or hemisphere is there, compulsorily you have to do isometric projection only. When it is not there, like these type of solids, you can as well do isometric view also, but since isometric projection is asked, I have converted everything into ISO 80, ISO 80, ISO 20 and all that. Okay, now even here ISO 50, ISO 50. Okay, this is height is 70. Now as you know, only this is isometric, and these two are called as generators, which are non-isometric because they are not parallel to any of the vertical edges. Okay, this is non-isometric, this is non-isometric. Okay, and this portion you have to break here, split here, and this portion you have to make it light. Okay, now the procedure is this solid has to be placed here. Now for that, take one line, mid to mid line. Since this is parallel to this is parallel to this, both are isometric lines only. In that way, you get the center here. And even here, the center is already here. Now, what is the best way is, do this separately in the way I have told you in the earlier sessions. Then move the entire cone with respect to this point. Pivot point is C, and coincide with this C. Okay, once you do this, you have placed one solid over the other, more or less your work is completed. But now, as you know, in when solids are placed one above the other in isometric projection, it is always you have to darkening procedure is always from the top solid, top surface. Now top surface is a point, just forget about that. Left surface and right surface cannot be meddled with because it's a curved surface. Hence you just join only this generator, and this particular portion is anyway darker, and this portion anyway is light. Then come to the bottom solid. Bottom solid is left surface is seen, right surface is seen. Important thing is top surface. When top surface is seen, this portion, since it is merged with this, since it is blocked by the top solid, this portion you make it light. Okay, you make it light. In that way, you have completed the isometric projection of a cone seated centrally on a square prism of sides 80 and height 20. Okay, isometric projection is over. As I told you in earlier sessions, you can actually stop at this. This is the isometric projection. Now you see here, you please understand, this is very important to you for the next chapter and all that. Okay, please observe. See here, let us say this is the direction of front view. What you get in the next chapter, they'll give the isometric projection, they'll ask you to draw the orthographic projection. Okay, when you look from here, okay, first concentrate on the front solid, bottom solid. When you concentrate on the bottom solid in the front view, okay, in the front view, that is on VP, You write 80 by 20 rectangle, no? That's what I've written. 80 by 20 rectangle I've written. Okay. On VP. XY line. VP HP you write. Okay. 80 by 20 rectangle you draw. Okay. And in the top view, it is a square, no? The square 80 you draw. Take the projectors from here only. Darken this 80. That means looking at the front view 80 20 and looking at the top view 80 square, you come to know that it is a square prism of sides 80 and height 20. Okay. Then you come to the second solid. When you are looking from here, this cone will look like a triangle. That is what I have done. This cone will look like a triangle and height is 70. Okay. So 70. And in the top view, this cone in the top view will look like a circle. This is the circle. Okay. Now, looking at this, this is 50. This is 70 means looking at top view and front view only, you can say the top solid is a cone because top view is a circle. Cone of diameter 50 and looking at the front view, you can clearly say it has a height of 70. And in the same way, as I told you I told you earlier, looking at the base solid also, it is 80 by 20 in the front view, 80 square in the top view. Looking at top view and front view, you know very well, when top view is 80 square and height is 20, it is a square prism of sides 80 and height 20. Okay. In that way, you are able to complete the orthographic projection also. Okay. But for the examination, when they ask you isometric projection, you can actually stop at this. Now from I have done orthographic projection in this way. This you need not do in the exam at this stage. This you do it in the next chapter. But you should clearly know the concepts, how this front view has been drawn, how this top view has been drawn. Okay. Now there is another problem here. Now you see here, there is another problem here. Where they have said, it's a rectangular prism 60 by 100 and thickness 20. Okay. This, as I've told you earlier, in the earlier sessions, 1 to 5 sessions, you draw the isometric projection. That is, take the original, multiply by 0.816 and convert into ISO 60, ISO 100, ISO 20. You do this first. Immediately in the same screen, you do this also, square prism of sides 40 and height 50. 30 degree, 30 degree, even here 30 degree, 30 degree. In that way, square prism also, you do it, make it ready. Okay. Now the problem is, these simple problems, what they ask you in the exam, you should not do any mistakes. It's all simple problem. This has to be placed centrally over this. Okay, centrally over this. For that, what you do is, this, anyway, top surface is darkened, left surface is darkened, right surface is darkened, all other things are light. Even here, top surface is darkened, left surface is darkened, right surface is darkened, all other things are light. Okay. Now, this solid has to be placed centrally over this. For that, what I'll do is, I'll get the center here. You see here, I'll center to center isometric line you draw, center to center isometric line you draw. Isometric line, why I call it as, it is parallel to this, and this line is parallel to this, which will undergo 0.816 reduction in length. Okay. Get C. In the same way, this also a line parallel to this. This also center to center line parallel to this. That is center to center line, you draw, get C. Now what you do is, move this don't copy, move with respect to this point C. That is, moving point is C. Move with coordinating point as C. You fix this point and bring it here so that this C and this C will coincide. Okay. Now once you do this, okay, you know clearly, a square prism of size 40 and height 50 is seated centrally over a rectangular prism of 100 by 60 and height 20. Now please see here, the important things in these cases are visibility. Visibility means you should always start from the top view, top solid, the top surface, top solid. Now the top surface is this, darken the top surface, darken the left surface, darken the right surface. This anyway has to be done properly. Okay. I'm telling you, the darkening procedure is always top solid, top surface. Top surface should be seen, left surface should be seen, right surface should be seen. Then come for the bottom solid. Top surface. Top surface you can't see in this region, correct now? In this region you cannot see, that is the top surface. In that way you split here, make this portion light. Okay, make this portion light. In that way this portion has been made light, and top surface and left surface, right surface anyway is seen. This becomes the isometric projection of two solids, one above the other. The bottom solid is a rectangular prism 60 by 100, thickness 20, and top solid is a square prism of sides 40 and height 50. Okay, you see here, I'll just, you are actually stopping at this stage. Draw it as isometric projection, you stop at this. Now to introduce you about the orthographic projection. Okay, in orthographic projection, the next chapter, in case there is a direction in this way, once there is a direction this way, this is the direction of front view. I can give the front view direction here also, no problem at all. If I give front view, if I look from here, how it front view appears, how top view appears, it has to be drawn. But I have given the direction of front view as this. If I look in this direction, how it should be seen, I have to draw. Okay. Now first you concentrate on the front solid. Now front solid, that is bottom solid. When you're looking from here, bottom solid, it is 100 by 20. No? See here, correct? 100. This is 100 by 20, bottom solid, front view. Then immediately come to the top view of the bottom solid. It is 100 by 60. This is 100 by 60. Looking at 100 by 60 top view, height 20, you can clearly say it's a rectangular prism, base sides 100 by 60 and height 20. You can clearly say it's a rectangular prism. Then come to the top solid. When you're looking from here, height is how much? 50. 50 I draw. 50 I draw. If you come to the bottom here, the top view of the top solid, no, it's a square 40. Looking at the top view, 40 square and height as 50, you know clearly it is a square prism of sides 40 and height 50. If this 50 had been 40, you would have said it's a cube. But it is 50, height is 50 and the square is 40. That means it's a square prism of size 40 and height 50. Okay. In that way, looking at this, what we call it as orthographic projection, we'll clearly come to know that there are two solids, one above the other. And looking at the base solid, that is this, it is 100, that is the height is 20, and in the top view it is 100 by 60, means it is a rectangular prism 100 by 60 and thickness or height 20. And second solid, that is top solid also, look at the front view, look at the top view. Look at the front view means 50, height is 50, and if you see the top view it is a square 40, that means looking at the front view and top view you can clearly say it is a square prism of sides 40 and height 50. This is called the orthographic projection. Please remember, in so many universities, orthographic projections will be given. Looking at the orthographic projections, you should draw isometric projection. Okay. For the universities, for the VTU and NMIT and so many private universities, okay, and all that, when they ask you isometric projection, they might give in the form of sentences. Actually, you can stop at this only. You can stop at this. But remember, you should clearly know this also. This will be very, very helpful, particularly later in the post-engineering career. This concept will be very helpful, because looking at this, you should know what exactly is happening. That is how the solids are placed and what are the dimensions of each and every solid and all that. Okay, this, I think that things are pretty clear. This is the isometric projection of two solids one above the other, and this is the orthographic projection. Both, if you know how exactly to manage, it will be very good. Okay, we have come to the end of this session. Thank you very much for watching.